In this video, we're going to talk about Taylor polynomials. So we often use Taylor polynomials to approximate functions. And a Taylor polynomial is just I think, like I said before, a partial sum of a Taylor series. And there's two different ways to talk about Taylor polynomials. You can talk about the degree of the polynomial versus the order of the polynomial. So fifth degree polynomial just means we're writing a polynomial that has the highest power of 5. A fifth order Taylor polynomial means that I'm going out to, I'm doing the first 0 through 5 terms. So order refers to the derivative that we're using. So remember, n corresponds to the derivative, sort of. So this would just mean go out till n equals 5. This would mean make a fifth degree. And we all know what degree means. That just it's the highest power of the polynomial. So if I'm writing a fifth degree Taylor polynomial, for f of x, what is that? X cubed e to the 2x. So we've already found the Taylor series version of this. That's what that original one was, right? Yeah. So we're going to grab that, but we're going off of this. So if it's a fifth degree Taylor polynomial, we're just going to start plugging in numbers for n until we get a fifth degree. So when I plug in 0 for n, I get 2 to the 0 times x to the third over 0 factorial. And that, of course, would just be x to the third plus, because it's a summation, we're just adding each term, right? I plug in 1 for n, and I get 2 to the first times x to the fourth over 2 factorial, which that would just be x to the fourth, wouldn't it? Because the 2's cancel out. And then I plug in plug in 2 for n, and I get 4 times x to the fifth over, whoops, I made a mistake there. That's 1 factorial. Because I plugged in 1 for n. So that would be 2x to the fourth. And then this is going to be 2 factorial. So the 2 factorial, of course, is just 2. So that would give me 2x to the fifth. And then I'd stop because I got to a fifth degree polynomial. So this would be the fifth degree Taylor polynomial. And I could use that to approximate f of x. Now this is a Maclaurin series, so it's centered at 0. So we could do a quick check and say, okay, what is f of, say, 0.1? We want something close to the center. That'd be 0.1 to the third times e to the 0.2. And that would be approximately equal to, I grab my calculator, clear. Let's see, 0.1 raised to the third power times e to the 0.2, and we get 0.0012214028. Now let's do the same thing down here. We're going to do 0.1 to the third plus 2 times 0.1 to the fourth plus 2 times 0.1 to the fifth. Oops, I did that wrong. Let's do 0.1 to the third plus 2 times 0.1 to the fourth plus 2 times 0.1 to the fifth. And this is going to be approximately equal to 0.00122. And notice what we have. I mean, it doesn't go any further than that, but notice it matches that those first 5 terms. So you can see that's pretty powerful that it only took 3 terms to match it out to 5 decimal places. So that's a pretty good approximation. And you can tell if we put some more terms in there, this is going to be even better approximation. Okay, so now let's do the 5th order Taylor polynomial. So 5th order, of course, would be these same ones. It would be x to the 3rd plus 2x to the 4th plus 2x to the 5th. But we keep going because we haven't got to end of the 5th yet. So I plug in, so the next one would be, I plugged in 2 here, so I plug in 3 next. And that would be 2 to the 3rd, which would be 8 over times x to the 0, 1, 2, 3, x to the 6th, all over 3 factorial. And the next one would be 2 to the 4th, which would be 16 x to the 7th, all over 4 factorial. And then the last one would be 2 to the 5th, x to the 8th, over 5 factorial. So then I'll simplify this, x cubed plus 2x to the 4th plus 2x to the 5th plus, now 3 factorial is just 6, so that would be 4 over 3. So 4/3 x to the 6th plus, and 4 factorial would be 4 times 6, which would be 24. 16 over 24 will go into, will become 2/3 x to the 7th. And then here we actually have 32 over 32. No, what am I saying? 5 factorial. It's not 32. So that would be 32 over 5 times 24, which would be 120. So that would be, what, 4 going there 8 times, 4 going there 30 times, that would be 4/15. So that would be 4/15 times x to the 8th. So this would be a 5th degree Taylor series, and that would be a 5th order, or not Taylor series, Taylor polynomial, sorry. Taylor polynomial, Taylor polynomial. 5th degree, oh whoops, that would be a 5th degree, that would be the 5th order Taylor polynomial. So yellow goes with yellow, and blue goes with blue. And just for fun, if you want to, you could plug in 0.1 into this new one, this 5th order Taylor polynomial, and see how much closer we get to what the calculator did. Okay. Alrighty.